Hello, in this video I am going to solve question number 7 of this national exam. How many solutions are there to the equation tangent to nu equals to 0.7 within the interval 0 degrees less than or equal nu less than or equal 360 degrees? Pause the video at this point and give it a try. Okay, tangent to nu is equal to 0.7. This implies that 2 nu is equal to tangent inverse of 0.7, but because we know tangent is periodic with period 180 degrees, according to what we learned in the lesson, we had to add any integer multiple of 180 degrees. Here n is an integer. N belongs to the set of integers. But of course this is 2 nu. I want to find nu. So I divide this by 2. I have to divide this by 2. I have to divide this by 2 as well. So the left hand side becomes nu. The right hand side becomes 1 over 2 tangent inverse of 0.7. The next one becomes n times 90 degrees. Okay, but because this problem is given in that part of the national exam that you are not allowed to use the calculator, so you cannot use the calculator to estimate this number. So you have to find a different way to do that. Okay, so if you don't mind, let me give it a name. So let me call this angle theta. So what do I have now? I can say nu is equal to theta plus n times 90 degrees. N belongs to z, of course. So this is the set of all possible solutions. Okay, now my claim is that this angle theta is below 22.5 degrees. How can I show that? I show that this angle is less than 45 degrees. And that is also obvious because 0.7 is less than 1. So tangent inverse of 0.7 is less than tangent inverse of 1, but tangent inverse of 1 is 45 degrees. So this means that this angle is less than 45 degrees. So when I divide it by 2 to get theta, theta will be an angle less than 22.5 degrees. So now I draw the unit circle for the continuation of the problem. Okay, so now let me draw the unit circle. So this is the unit circle, and then we realize that theta is an angle less than 22.5 degrees. For example, let us say that this is 45 degrees, the angle bisector, and if I divide this by 2 again, it becomes 22.5 degrees. So that angle is below this angle. Okay, so let me just imagine that this is the angle that I have. Okay, so let us imagine that this is my theta. Okay, so this is my angle theta. Okay, so now if I go back into the formula here, I am supposed to choose those values of integers n so that the final angle will be somewhere within this interval. Of course, it is clear that I cannot choose negative values for n because theta is less than 22.5 degrees. Even if I choose -1 for n, then I will end up with a negative angle, which is not acceptable. So the first choice that is acceptable is for the case where n is equal to 0. Okay, so if n is equal to 0, then the angle nu becomes theta itself. So this means this is one of the points that I have here. But now what I have to do, I have to give n equals to 1 to see if it is acceptable. Then theta, so nu becomes theta plus 90 degrees. And if I choose n equals to 2, then it means that nu becomes theta plus 180 degrees. Still, this is acceptable because theta is less than 22.5. If I choose n to be 3, then nu becomes theta plus 270 degrees, which is still acceptable. But of course, if I give n to be 4, this will go beyond 360 degrees. So this means that my equation has only 4 solutions within this interval. And if you want to draw them, here, this is the first one. This is nu equals to theta, and then I go 90 degrees more. Yes, I will get this angle, which is nu equals to theta plus 90 degrees. If I go 180 degrees more, I will end up here which is theta plus 180 degrees. And if I go 270 degrees more, I will get an angle in the fourth quadrant, which is theta plus 270 degrees. So the answer that I have to write here is just simply 4. I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.